So vanakkam. So we have been discussing about the microzonation work, okay, part of our engineering seismology course, okay, so lecturing. So we have talked about the global seismic hazard mapping done in 1992 by the Bhatia et al. And then how it was done and all. So then followed by we also talking about the global earthquake model GEM, okay, which was where they prepare a global scale seismic hazard map, okay, so for the different countries, like 30 countries, that 30 continent, the countries basically they carried out this work individually and try to collaborate and mix and then make it as a common platform where the procedures and then the mapping tool and then the mapping level remains same, okay, and then it has a option also whenever there is a change in the model and data, it can automatically update. So that was one of the beauty of this model. So this we discussed that they developed in the OpenQuake program, okay, so OpenQuake program they do, okay. So we have seen that as a India they are given iterative map where you can see the PGA distribution. So even if you pick up, okay, a particular point, for example I want to know what is the hazard at Salem. So you can see the hazard at Salem, this is the value you can see here, okay, this is the hazard at Salem. But if I go to Bangalore, even though it's marked all of them in the green with the range of 0.08 to 0.13, but you can see the variation. So such kind of iterative map or interactive map will be useful for the regional level planning and city level planning. So that is what we have to target part of the any microzonation mapping system, okay. So hopefully our future NDMA map which they are planning to produce will be having such kind of map city level where you can see the variation with respect to different part of the city, okay. So for example if you are in the Chennai city, you can see the what is the hazard value at the central railway station and what is the hazard value at Tambaram, what is the hazard value at Meenambakkam airport and what is the hazard value at Coimbatore, what is the hazard value at Gandhinagar and what is the hazard value at Madhavaram. So like that different places how the hazard value changes. So that should be clearly extractable and viewable, that kind of mapping system should be adopted. So why, as I told you that this is the macro scale map, it says a hazard range, okay, hazard value, but which does not consider a regional variation, okay. So then why these maps are very important, why they do? Basically these maps are estimated to know the exposure and risk of the particular country, okay. So when you are talking about the hazard analysis, okay, basically when you are talking about the hazard analysis, hazard different hazard, okay, not sorry hazard analysis, when you are talking about the different hazard, we also talk about the risk and exposure. In the first class we have told that which are the countries are highly exposed to a seismic risk. So how they say based on this kind of global scale studies, okay. So the idea of this map is basically to generate a risk and exposure map using this, not for building design. Basically the global level we know that which are the countries are highly risk seismically, which are the countries are flood risk, which are the countries are drought risk, okay, like that. Why this is informations are needed? People who want to invest, as you know that now the global, the international business are the each country can buy from other countries, they can invest and produce something. People who want to invest their money to make something on country level, they want to know that what is the status of this one, okay. So for example somebody want to start a factory in India to produce something, okay. So then they look at this seismic hazard map, okay. Then they look at the what is the risk associated in that. So they try to invest where is the low risk region, so that even something happens their factories are safe with respect to earthquake, not the economical. Similarly they look at several risk factors for the investment, wherever the low risk is there they go for that. So such way like preparing that kind of larger scale and continent to continent, how this region is basically involved is basically this kind of studies are done. There is a agencies or companies, okay, they do this kind of systematic analysis and produce a local scale map. Okay, so there is RSM, okay, risk model solution. There is one company who produces and give input to the insurance company, okay, who do the housing insurance. Okay, they decide that this area I want to take insurance, housing insurance, how much the my premium. That for that this kind of data and are useful. So the global seismic risk map, okay, is comprised 4 global maps. Okay, the main map presented a geographical distribution of average annual loss normalized by the average construction cost respective country due to the ground shaking, residential, commercial, industrial building, considering the contents and structural and non-structural component. So they prepare basically the risk, how much financial loss. For example, if I start a factory here, if the earthquake comes, how much the financial loss I incur, 1 year, 5 years, 10 years. Such kind of understanding will be done using this kind of global level data. Okay. Then the normalized matrix allows direct comparison of the risk between the countries with widely different construction costs. It does not consider the effect of the tsunami, liquefaction, landslide and fire and earthquake. You can see that this cost what the risk right now they are given in the global earthquake model only consider the direct ground shaking hazard, not the tsunami, liquefaction, landslide and fire. Okay, so because this minor level information incorporating in the global level will be very complicated. Okay, but at least it give you the where it stands with respect to the direct ground shaking hazard in the bedrock level condition. The loss estimations are from the direct physical damage to the building due to the shaking those infrastructure. Indirect losses due to the business interruption are not included. It's only the because that building damages, the earthquake happens, what is the earthquake loss. So this they studied from the previous earthquake and used to model this kind of damages. So the average annual loss are presented on a hexagonal grid with a spacing of 0.3 by 34 decimal degree, approximately 1000 square kilometer at equator. The average annual losses were computed using the event based calculator of the OpenQuake engine and open source software seismic hazard and risk analysis developed by the GEM model. So how this map was developed, they were given actually. This was map produced from the hazard and risk analysis developed by the GEM Foundation, which was comprised the data from the different region. So the seismic hazard exposure vulnerability models are employed in these calculations were provided by the national institutes or developed within the scope of regional program or bilateral collaboration between the teams. This global map underlying database are based on the best available and publicly accessible data set and model. So that means the data set, as I am talking about the availability of seismic data, how important which produce a more reliable zonation map and risk map, that is how they say. So due to possible model limitation, regions portrayed with low risk may still experience a potentially damaging earthquake. So this is what we have discussed. So there is a chances that even though it's marked as a low risk, there may be high hazard due to the damaging earthquake because of the lack of model and data at a particular place. So the GEM risk map is intended to be dynamic product such that it may be updated when new data set and model become available. Release of updated version of the seismic risk map are anticipated on regular basis where there will be risk. So this is the global risk map. Okay, so this risk map will give a average annual loss, okay, due to the earthquake in USD. Okay, the normalized by the construction cost of the USD per meter square on the hexagonal grid of this much size about a 100 kilometer region. So you can see it varies from less than $50 to about $25,000 at a particular place. So now we can go to the iterative map in the screen. So as I told you that, okay, so this is the earthquake hazard map. So let's see the risk map. So the risk map, you can see this is a risk map. So you can go very minute level. So, here you can see that in our hazard map this entire area, okay, this entire area basically so this entire area basically marked as a same hazard value, but when you go to the risk, okay, you can see that the Bangalore has a higher USD loss when compared to nearby area. You can see here. See. So, the region, country, so what, how much the loss, everything you can get as a iterative information. See. So, this is also annual average loss. So, such kind of maps are put. So, people want to invest. For example, they look at Southern India as the option. Within Southern India, they look for okay Bangalore, Mysore, Chennai, and Hyderabad. Like that, they look at. Apart from looking at the potential other factors, they also consider this as a factor. If they look for India, again they look for that North India, South India, how the Delhi, how is the UP, how is the Bangalore, how is the Hyderabad, how is the Telangana, something like that. They look and take a decision for the proper investment. Okay, this risk map will help on all those kind of decisions. Okay, so this is the overall image file. You can get the interactive map from this website. As I told you that the entire class of the last and this class what we are talking about the GEM from this website. So, I should thankfully acknowledge them for providing this information, which is useful to know how the zonation maps are important for different aspect. Okay. So, this is a risk map. So, from the risk map they also develop a exposure map. So, the exposure map presents geographical distribution of residential, commercial and industrial building at a particular place. So, the number of buildings presented in the hexagonal grid where the spacing of grid, as we talk about the risk, basically used this exposure data. Data set employed for develop exposure map are provided by the National Institute. So, the same concept like it has been provided from the national level, and also are they collaborated and collected from that. The global map underlying database are based on the best available publicly accessible data. So, all the data which is accessible they use. So, some of the places even though it is marked as a low risk, but it may expect a high risk, as we said that the data and models are very important, the lack of data. So, this is saying that the number of buildings in thousands in that particular area. Exposure means if particular hazard comes, which are the building going to suffer more damage, how many buildings, okay, that is you can see here. This is basically the exposure. You can see the India actually has a more exposure because of the poor building construction practice and codal provisions. Okay, that is why you can see the more exposure than other places. So, other regions where the building also not there, here building is there and the construction practice also problem. That is why you have the more exposure. So, that exposure and risk may result a number of fatality. You can see the here global fatality map. So, estimate average annual human loss due to the earthquake. You can see basically the earthquake human loss. So, North India you can expect at least per year so many people die due to the earthquake in the region. Okay. So, this is the details provided from their risk and analysis where they consider data from the olden so data from the world earthquake, which we will discuss what are the earthquake they consider for India when we narrow down our study for the Indian region. So, here you can see legend. So, the number of building exposed, residential, commercial, total. Okay. So, how these data are there, I mean arrived and calculated using that, they say that it is a risk and a exposure in the each region. Okay. So this model global level they consider and prepared throughout the globe, and they publish, which will be useful for the different level of information people want, basically the investor, okay, and then the any kind of future planning, somebody want to buy a big land in India, so they look for all these things which they doesn't have any information, okay, so they look for this one. So they then basically accordingly they will decide what is the to be done. So let's see what are the information gone into the map from India. Okay. So the Indian, okay, seismic hazard model of India, the basically cover Indian subcontinent with hazard value estimated by the Northern Timbajam during 2012. Okay. So basically the work carried out by Northern Timbajam during the 2012, okay, has been considered as a part of your global earthquake model. So this model covers India, Bangladesh, Bhutan and Nepal. The model has been updated and translated from the original format to the open quake software, where engine which collaborates with the natural resources of the Canada. So okay, the people who are taken the data and try to incorporate that. Additional information, materials, documentation about the implementation of the model can be found. Okay, this website, if you go to that website, you can find here more information about the what are the models they used. I will just to show you that, because it is very important when we talk about the any model. So how this model is better, okay, how far it's reliable, okay, what are the conditions they used. So here I should also acknowledge that the Timbajam, okay, the scientist Timbajam, one of the pioneer person who work on hazard analysis, particularly he contributed, okay. So extensively in the area of this hazard analysis and seismic microzonation mapping, okay. So his contributions are extensive on this area. So the initially basically from the IAC Iyengar and Raghukant, then followed by the Timbajam and Nath, okay. So those are all the pioneer people who are actually senior to me, they but contributed extensively on this. So this is the basically the iterative map what they produce from this study. So where you can see that the tectonic, okay, the PGA distribution, gridded seismicity map, you can see whatever map you have seen, no? This is the ingent scale, how you can see the variation. Okay, so here you can see the so you can get all the information which is considered in the mapping. Okay, so that is what you can get from this iterative Indian map. Okay, so you can see even the tectonic boundaries, and then if I want to remove the PGA but want to get other information, so you can see. So the tectonic boundaries, okay, so how they consider a different tectonic boundaries in the consideration for arriving a particular model. So that is what is basically shows. Okay. So this information about the tectonic overview as discussed here. So what is the tectonic overview? The hazard model what they consider, okay, source model, okay. So the three source model, a single setup aerial seismogenic source model, two smooth gridded point source model. So then epidemic uncertainty considered through the alternative. So here they didn't use a linear source, they consider a point source and aerial source based on the data which is available. So this is the ground motion characteristics model which used to estimate a hazard value. For example, active crust region, which is the North India, they used this. Sorry, active crust normal fault mechanism, they used this. Active shallow crust side slip reverse, they used this model. So the intraplate regions like the southern India, they used this all the ground motion model. What is the weightage factor? Because in PSHA when you have the option to combine different GMPs with the different weights, okay. Then the stable crust, okay. So then the subduction interface, subduction intraslab and subduction intraslab. So these are all the GMPs they use and using this they estimated the PGA value. That PGA value only you are seeing here, you can see. Okay, so this is the combined. So if there is a change in the model, there is a option they can incorporate and revise a map. Okay, so from this website you can get that information what they have considered and use. So this is how your PGA distribution map. Okay, so this is actually the so maybe the risk, I think risk value on the particular location. So you can see how the values are regional scale is estimated to represent in the global scale. Okay. So in this actually to estimate a risk and exposure, they consider basically the data from India. What are those data? Basically they consider when they do this analysis of 2018, the population. Okay, they consider 1333 million people, the population growth rate so much, the GDP million so much, GDP per capita so much. Okay, so then the total saving, okay, so billion so much, life expectancy so much, Gini index and human development index so much. So these are all the factor, social factor which goes to exposure and risk. So to take a risk, they have considered residential, commercial, industrial. So much asset replacement cost, so much. Okay. Then the major earthquake what they consider actually Gujarat 2001 earthquake, Kilari earthquake and Somali 1991 earthquake, where the number of fatalities are available with the building information and other details. This is the information they use. Finally, they produce seismic hazard map, which is considering the ground motion prediction equation what we discussed earlier, and this is the way of distribution of the hazard. Okay. So this map is gone to this one. Then the exposure map, value of USD per Indian scale, you can see the how much the USD in Indian scale. So there are places where the exposure of these regions are very low, even though the seismically it's very high hazard. You can see that exposure and hazard. The risk, okay, the average annual loss you can see here. So this is actually combination of both exposure and risk. So where some places you might have seen the higher risk but lower exposure, some places you have seen the higher exposure and lower risk. By combining this you can see the value of in USD, you can see how much. So the average annual, okay, the average annual drop represented long time loss value per year due to the direct damage caused by the earthquake, ground shaking of residential, commercial and industrial building due to those three earthquake data they consider, and then they try to arrive these maps. Okay, similarly seismic average annual loss ratios, okay, which are the place you get more loss, which are the place you get less loss when comparing the highest and lowest in the region. So the annual average loss ratio of the country or subdivision represented the average annual loss normalized by the total asset replacement cost within the country. This is how they arrived. Okay, you can see the residential, commercial and industrial, how much the commercial. So industry actually very less. So the 200 years return period loss represented long term mean loss value due to the direct damage caused by the earthquake, ground shaking, residential, commercial stock, and considering the this one. So whatever non-structural component and the building content in that, you can see how the loss. So if you want to do the long investment, you will have the more loss. So the people look for the short investment, they may experience a. So this is again a region wise how much the loss, annual loss you can expect West Bengal, Bihar, Punjab, Delhi, Uttar Pradesh. This is the example. So you can get like this here several region level and decide that where you want to invest, okay, where you want to start your factory, where you want to start your. So as I told you that this kind of global earthquake models, okay, GEM or all those, the objective is not only to tell how your country with respect to other countries in the world, and also it give you the risk and exposure level. So here you can also note that this exposure level and risk level not consider the liquefaction, tsunami, landslide kind of hazard taken into account. Particularly the earthquake, even though they consider these three earthquake, but these earthquake damages not explicitly account all those things in detail. Okay. So this kind of map has to be frequently, okay, so updated and prepared. And so, but this is with respect to global scale. There is a set of community people who work on this and then publish data, okay, and then update, okay, for the interest of the entire global community. So, here you can see the people who are involved and sponsored and developed this kind of studies, you can see. So, okay, there are so many people, see, all of them big companies on each country, and then the big universities, okay. So, they fund and invest money on all these things, because the people who are investor from these countries are using this data, okay. So, this is the global one, but this maps, okay. So, not only with respect to the preparation it ends, okay, it has to be also updated frequently. That update should be consistent, okay. So, what kind of information we need to update? So, the map and risk estimates display a country profile. Underlying database are based on the best available and public accessible data set and models, which we have seen that the seismic hazard exposure vulnerability model employed in these calculations were provided National Institute based on the scope of regional program and bilateral collaborations what they made. The criteria used to selection of major earthquake displays the country profile considered earthquake causing the largest number of fatalities that occurred in the last 100 years. So, they consider this, the fatality due to tsunami were excluded, okay. So, that was where the risk and fatality models are considered. So, there are many big earthquakes in India which caused extensive damage and fatalities, which does not have large amount of the recorded data and the intensity maps, particularly on Himalaya, Nepal, Bihar, Nepal earthquake, okay. So, the Shillong earthquake, those are all, but those are all not modeled here. So, obviously, the model earthquake 3 what they consider, whatever limitation they have will be carry forwarded in the fatality and risk prediction. But however, as on now, this is the best model and data one can expect. So, but developing this data and models may not be sufficient, it has to be frequently updated. So, frequently updated, I will give you the example how the US system develop a model and maps similar kind of way for the US. So, this is basically the USGS website, seismic hazard map and site specific data, which is published every year. You can see the short term model and long term model for the entire US. The short term model, let us see for the 2018. So, you can see the National Seismic Hazard Model, which gives chance of potentially minor damage ground shaking in 2018. 2018, which are the place how much the ground shaking potential percentage loss you can expect. So, similarly, you can see 2007 they developed, 2009 they developed, which help for the short term investment plan and other things. So, this consists of the detailed data and analysis which they collected from the different long term data. You can see the long term data. So, you can also see that the long term data provided, okay, this is the long term data. So, you can see 2008, okay, map has been given, which is valid for the next 4 years. You can see they developed 96, 2002, 2008, 2008 and 2014 and 2018. So, earlier they used to do every 6 years, now they are doing every 4 years. So, these kind of maps, microzonation maps or hazard analysis maps or exposure map or risk map need to be frequently updated, okay. So, soon after the big earthquake or soon after the 4 years or 5 years gap, depends upon the availability of tool and other things. That means, once they release a map, we should not keep quiet saying that I have done this map, it is sufficient. So, why I say this statement, next class we are going to talk about the Indian seismic zonation map, okay, how the zonation map is prepared, what is the discussion we are going to make on that. So, you can see that these people prepare a hazard zonation map and also a risk map and a exposure map with time interval. Let us see how our maps are prepared in the India, how these maps are reliable. On the next class we will be discussing that. Next class I will also give you the glimpse of seismic microzonation work done in Bangalore. even though it is submitted as a report, there is no interactive map has been generated, but still the methodology steps and the parameters gone to prepare a hazard index values. I will give you the in detailed way so that you will understand how the zonation map is very important, and then followed by the Indian seismic code and zonation map discussion in the next class. So thank you very much for watching this video. So we will see you in the next class. Thank you.